Hey guys, a couple weeks ago we talked about polyhedron. Now we're going to break it down to a specific subset of polyhedron today, talking about prisms. So what a prism is, it is a polyhedron with two congruent bases that are also parallel, and these two bases are connected by parallelogram faces. So, you have probably experienced polyhedron before and experienced prisms before, and if you haven't, you have not been aware of your surroundings, because we used to take geometry class in a giant polyhedron. That polyhedron was a rectangular prism. Prisms are named by the shape of their bases. Now, our classroom was a rectangular prism. It was just 6 rectangles, the 4 walls, the floor, and the ceiling. And this is what it would look like if we just filled it with concrete and then removed the walls. Now, when we sketch these, we also like to draw in the hidden lines, the edges that you wouldn't see. So this is a rectangular prism. Now, what's special about a rectangular prism is that any pair of sides can be the bases, because this front and the back, they're congruent rectangles and they're parallel. This top and that bottom, they're congruent rectangles and they're parallel. This left and right side, they're congruent rectangles and they're parallel. So any side can be the bases, or any pair of opposite sides can be the bases. Obviously, the front and the top can't be your bases. It would have to be the front and back, top and bottom, or left and right. So let's look at a prism that's not as ambiguous as a rectangular prism. Let's do a pentagonal prism. So we've got pentagon, and then a bunch of rectangles connecting it to another pentagon below. And we also have hidden lines here. I am not expecting you guys to be proficient at drawing prisms at this point. I have drawn literally thousands of prisms, so and still sometimes when I draw it, it looks like a hodgepodge of segments, and it's very hard to tell what it looks like. So I'm not expecting your diagrams to be perfect, but if the more you practice, the better they'll come out. Now, the two pentagons, those are our bases. The two pentagons are our bases. The rectangular faces that connect the two pentagons, what these are called, are our lateral faces. We name our prisms by their bases. So this would be a pentagonal prism. If our bases were triangles, it would be a triangular prism. That would look like a Toblerone. If our bases were octagons, it would be an octagonal prism. So we name our prisms based on the shape of the bases. Now, if the lateral faces are all rectangles, that means that all of these are right angles. It would be a right pentagonal prism. So if all the lateral faces are rectangles, it's a right pentagonal prism. If they are other parallelograms, and they have to be parallelograms because the two bases have to be parallel to each other in order for it to be a prism. So they have to be parallelograms. But if there are other types of parallelograms besides rectangles, they would be oblique oblique prisms. We're not going to do much with oblique prisms. We do a little bit more if we were in class, but really, they don't really come up. They're not very useful figures. They don't really come up in nature or anything. Oblique cylinders will come up more often, but not really prisms. But they do exist, so I just want to mention them. Now, the edges that form the base are appropriately called base edges. And the edges that connect the lateral faces are called lateral edges. So these are the parts of a prism. A prism always has two bases, and then the remaining quadrilaterals are all the lateral faces. If it's a pentagonal prism, you will have 5 lateral faces. If it is a decagonal prism, you'll have 10 lateral faces. So the number of sides of the bases, of base edges, on one base is the number of lateral faces you'll have. Now, all of our faces are polygons. All of our faces are polygons. So, we could actually lay it out such that all the polygons are on the two-dimensional surface. And we could lay it out in a way that we could cut it out and fold it back up. So let's say we had that pentagonal prism. We have our pentagon over here, and then we have a congruent one over there. Pretend that this is congruent and that my diagram is not just awful. All right, so we have our two bases, base 1, base 2. I'll put a subscript to differentiate, even though it doesn't matter. And then these two congruent sides will be joined together by a rectangle. But these two sides these faces would fold up, and this would fold up, and these two would match together. And these will go there. Hi, buddy. Nope, don't walk in front of the camera. Sorry, my cat's on the table. See, you just saw his tail. And these two sides would have a lateral face connecting them. And then the remaining sides would have a lateral face connecting them. So if you were to cut this out, which if it were paper, I would, but it is not, you could fold these pentagons up and these lateral faces would wrap around, creating this. This outlay of the surfaces of the different faces of the polyhedron is called a net. And any type of any type of polyhedron can be broken down to a net. And it is a two-dimensional representation of all the surfaces of a polyhedron. Now, these are all two-dimensional figures, so we can find the area of these two-dimensional figures. And every prism can be organized like this, as a stack of rectangles, and then the two bases on either side. This base area and that base area are the same. But these rectangles are not necessarily the same. But what is the same about them is their height. The reason I'm calling this the height of the rectangle is because that's the height of the prism. The height of a prism is the distance between the two bases. Even if it's an oblique prism, if you have an oblique prism, the perpendicular distance between the two bases is the height of the prism. So that's why I drew the height this way. So this rectangle has the same height as the prism. And then if you think about it, this matches with that with that, this with itself, those two together and those together. This side of the rectangle is all 5 of those sides. It's the perimeter of the base. So the area of this big rectangle is the perimeter of the base times the height of the prism. This is called our lateral area, or LA for short. And this is how you can help find the surface area of a prism. Regardless how many sides that has, regardless how many sides the base has, that lateral area is always the perimeter of the base times the height. And the total surface area is the lateral area plus the two base areas. Throughout this entire unit, capital B is going to refer to the area of the base. Throughout the entire unit, all of this surface area and volume, capital B is going to refer to the area of the base. And this is how you can find the surface area of the prism. That's how you can find the lateral area of the prism. But there's another measurement when dealing with three-dimensional figures, and it is not how much area the exterior occupies, it is how much physical three-dimensional space the exterior the whole figure rather occupies, and that's our volume. So I'm just going to draw a hexagonal prism. All right, I know it's a garbage hexagonal prism, but conceptually, the distance between the two bases is the height of the pyramid. Whether you measure it inside or outside, it's the distance between the two bases. It's always going to be the height, whether you measure it along this lateral face in the back, this lateral face in the front, the two on the left or the two on the right. It doesn't matter. That's going to be the height. And the top and bottom both have the same base area. Essentially what's happening is we are taking that base and we are stacking it up over and over and over again. And each of those stacks corresponds with a real number that can be assigned to the number line that covers 0 through h. So essentially we're having this base occupy from 0 all the way to h. The volume of a prism is the area of the base times the height. That's all it is. It's the area of the base times the height. So if you have just a cube, the area of the base is side times side, and the height is the side length as well, so it'd just be s cubed. If you have a rectangular prism, the area of the base is length times width, and then times the height of the prism, length times width times height. So this is volume of a prism. So we've talked about surface area, we've talked about volume, we've talked about nets. That's pretty much it for prisms. All right, have fun. Bye.